This is TWiT.
Mentioned a little bit the new iPhone, the A15 Bionic chip that's inside. Apple's been doing their own thing with their silicon for the last couple of years now, and it's been working pretty darn well for Apple. Google, on the other hand, we're kind of venturing into the era of Google's own silicon. And so we've got the Tensor chip, which is what Google's calling it, the Google Tensor chip. It's going to be found inside of the upcoming Pixel 6 and Pixel 6 Pro. That's going to be coming out sometime in the next couple of months. I'm guessing probably the end of next month-ish, somewhere around there. That seems to follow previous kind of patterns. Mishaal Rahman from XDA Developers actually published an exclusive look at the specs of the new chip because we have more details thanks to a source close to XDA. Mishaal is here with us now. Welcome back to the show.
Thanks for having me back on, Jason.
Always a pleasure. And I love that we get the opportunity to do it because when you put exclusive in your headlines at XDA, I know I'm reading through it. You guys have just some great sources, especially on something that is so kind of followed by Google fans and Android fans. We want to know all about what's coming up without firing off my my assistant like I just did. And so let's it's par for the course in this job. So let's start with the details that Google, at least at this point, has officially shared. What can you tell us about what they've detailed about the Tensor chip before we get into kind of the leaks and everything?
So Google has actually surprisingly unveiled very little information about the chip themselves. We've seen so many teasers from them about the Pixel 6. They've already announced the names. They're showing it in stores, although you can't get your hands on one. But apart from the name of the chip, which, as you said, is the Google Tensor, they've only confirmed a few high-level details, including the fact that its Tensor Processing Unit, or the TPU, will be employed to run the company's HDRnet computational photography software on every frame in a video. So basically, the company's industry-leading HDR plus software that currently runs on photos that you take from the Pixel phone will be run on every single frame in a video. So hopefully, the next-gen Pixel phones will be significantly improved in terms of video taking capabilities. They also mentioned that the chip will power several new on-device AI features, such as the ability to not only transcribe voice in real time, but also take that transcription and translate it in real time as well. And finally, they also mentioned that they will be introducing the second generation of their Titan M module. It's hardware security module that they include in Pixel phones since the Pixel 3, I believe. And they haven't specified exactly how that module has been improved, but they told us that it's the second generation module and it'll be called the Titan M2. Apart from that, they haven't mentioned anything else.
Yeah, and I mean, Google's doing the trickle effect. They have their strategy of releasing enough early on ahead of the official release of this stuff, which they've been doing for the last couple of years, kind of a strategy, it seems anyways, to get ahead of some of the leaks, to allow them to kind of control some of the messaging. That doesn't mean other information doesn't come out. It just means that it gives them the opportunity to kind of set the stage for what people are talking about leading up to it and getting more excited about it. We've had some other details kind of come to light along the way as well. Again, before we get to the CPU, which is kind of the primary stuff that you were able to get insight into, we've had some details about the modem, about the GPU, and I mean, either of those details, is there anything that really stands out to you from what we've gleaned on that? I mean, I know the modem, I keep reading that it's likely a Samsung modem for 5G. Like, why is that significant considering we're talking about Google Silicon here?
So it's significant for several reasons. First of all, when we first learned that Google was working on its own silicon for upcoming Pixel devices, it was heavily reported that Google will be designing the chip in collaboration with Samsung, and they'll be having Samsung fabricate the chip. So learning that it will use the Samsung Exynos 5123 modem, which is the rumored modem in question, basically confirmed those rumors. It's first of all good to know that a lot of those rumors, early rumors from mid 2020 are accurate. And the second reason it's significant is because to date, there have been very few 5G devices sold in the United States without a Qualcomm modem. There have been a very small handful of devices with MediaTek chipsets, and they've only been released within like the past 2 months, I think. So Google shipping a device in the US with a Samsung 5G modem, I think that'd be the first, because Samsung doesn't even ship their own 5G modems in their own phones in the US. They still use Qualcomm.
Right. Okay. And I mean, I suppose that in some ways allows Google to kind of focus more of its attention on what the Tensor can do. And like you said, a lot of that has to do with AI processing. That seems to be what they're really talking it up in advance. And that's a great thing. Don't get me wrong, because Google is a really great AI company when it comes to usability of these smartphones. A lot of my favorite features kind of hinge on that AI capability underneath. So if this is going to improve that, that's great. But I think a lot of people, myself included, would love to know that, hey, if Google's creating a new system on a chip for their devices, that they're taking everything into consideration, and things like just the usability of the phone outside of AI, like, speed of the processor and everything, that it's going to be capable, if not better than what's like comparative, if not better than what's already out there. So that leaves kind of the CPU as a large part of that. There was a Geekbench listing for the Pixel 6 Pro that came to light. It seemed to fill at least some of the gaps, but of course, like I mentioned earlier, you at XDA have a source that has an actual Pixel 6 Pro in their hands. Talk a little bit about kind of what we're learning there around the CPU configuration of the Tensor chip, and not just the configuration of it, but what that actually translates into for, say, an everyday user, if that's even possible at this stage to understand.
So first of all, what we learned about the CPU configuration of the Google Tensor chip is as follows. We learned that it will very likely have 2 Cortex X1 cores clocked at up to 2.8 gigahertz, followed by 2 Cortex A76 cores clocked at up to 2.25 gigahertz, and 4 Cortex A55 cores clocked at up to 1.8 gigahertz. So none of these cores are custom. They're all off the shelf. They are designed by ARM. And you'll find a lot of these cores in other chipsets designed by Samsung and Qualcomm. But what's unusual about the Google Tensor chip is the number of cores and the pairings of these cores. So the Google Tensor chip, if these specifications are accurate, and we believe they are, would be the first chip to have 2 Cortex X1 CPUs. The Cortex X1 is currently ARM's most powerful Cortex CPU on the market, and Qualcomm's and Samsung's latest chipset each only have 1 of them. So pairing 2 of them suggests it'll have a very significant power improvement. But what's unusual about this chip is that the other 2 cores that are in the performance configuration are Cortex A76 cores. Those were actually announced in mid-2018, so they're actually several generations old. They've already been succeeded by the A77 and the A78. And various members of the media that we talked to, including AnandTech's Andre, who is one of the foremost experts on mobile hardware, he is very perplexed by Google's decision to include A76 cores rather than the newer A78, because the A78 is, according to what ARM has announced, superior in regards to the 3 key areas that any mobile chip designer would care about, which is power, performance, and area. So the reason why Google decided to include these A76 cores is something we'll have to ask Google once they actually announce the Google Tensor chip alongside the Pixel 6. It's hard for us to rationalize right now why they may have gone this route, because we don't have the full picture of the actual chip. Until we actually have a die shot where someone tears down a Pixel 6 and takes a very, very high resolution image of the chip so we can label all the on-die components, we probably won't know like how much space these CPU cores are taking up and whether or not it was necessary for them to include these or whether they could have gone with A78 chips, etc.
I see. So yeah, it could be space, could be cost, maybe. I mean, you know, I suppose it's possible that Google's like, all right, we have a certain target for these chips. We have a certain target for our Pixel 6 and our 6 Pro. We don't want to end up with $1,500 phones. Who knows? Maybe they will be $1,500. I don't actually believe that, but I guess it's possible. But if Google really wanted to avoid that, like, could that be the difference here? Like adding dual A76 cores, could it be a cost savings measure more than anything?
So from what I understand, the cost saving argument doesn't really make much sense right now because, for one, the way ARM's business model works is that they license their core designs to chip manufacturing companies, and then whenever those chip design companies actually create a chip, ARM also gets a royalty from that. So the license that Google is likely paying to have two Cortex-X1 chips or CPUs, you know, if they're already doing two of their most powerful and probably expensive CPUs, it's kind of hard to see why they wouldn't just go for two A78s as well. Yeah. It's unlikely that the licensing difference, that the licensing cost is that significant.
Okay, well, that's notable then. Interesting. All right. Well, we know what you're going to be asking when Google actually allows for some open questions on this topic, and I'll be curious to see what that leads to. You also wrote that Google's AV1 decoder is hardware accelerated by the Tensor chip, and that we haven't really seen this before. What does that actually mean for end users?
So the AV1 codec is a royalty-free codec that is being heavily pushed by Google and various other companies in comparison to another video codec, HEVC or H.265. So these video codecs are used to encode video files in, and then whenever a device plays back those video files, it needs to have a decoder to decode those files. So the debate between AV1 versus HEVC is that HEVC requires you to pay a licensing fee, or not you, the consumer, but the company that implements a encoder and decoder has to pay a licensing fee, versus AV1 is completely royalty free. And in addition, AV1 is highly efficient at reducing the file size of video files. And as we know, video file resolutions are just getting bigger and bigger as smartphones and cameras are getting more powerful and powerful. So because video files are getting bigger, whatever you upload to YouTube or other sites are getting bigger, which means you need faster internet speeds to stream those files. So the advantage of having a codec like AV1 used is that it can compress those video files without losing significant quality. So if you were to employ AV1 everywhere, these streaming companies like Netflix, like YouTube, can save petabytes of data in the long run. And that also translates to lower bandwidth usage for consumers, which means, you know, you're not eating up your 5G data allowance or your home internet, meter as often.
Okay. All right. That's notable. In light of what we know right now about the Tensor chip, and I realize, you wrote that there's a lot we don't know about the actual GPU. There's certain details there that are going to be really instructive as far as how that translates into the experience of using the phone and everything. But based on what we know right now and some of this more expansive information that you're collecting, is it right to compare what Google's doing against what Apple has done with its A15 chip and the ones before it? Like, are they actually going after similar things or different? Like, are we actually comparing apples to apples here, quite literally, or apples to oranges?
Well, based on what we already know about the GPU that will be used inside the Pixel 6, it's not going to be a next generation device in terms of graphical performance. The GPU is already a known quantity. It's the Mali G78. And that was already announced, and it's already been employed in several devices, including the Galaxy S21, the international variant, uses a 14-core variant of that GPU. That Mali G78 can actually have 24 cores, as seen on the Huawei Mate X2, which is Huawei's foldable device that they only sell in China. So the critical information that we're missing here is how many cores will be used in the Mali G78 found in the Google Tensor chip. That will tell us what kind of raw graphical performance we should expect. Is it going to be as fast as the Galaxy S21 or the Mate X2, somewhere in between, or slower than both? And there are other factors that determine how good the GPU performance will be, including the clock speed, how aggressive the scheduler is for ramping up the frequency, etc.
Awesome. Well, we're kind of within that realm right now as we lead up to, Android 12, probably going to get an official release sometime in the next, 2 to 3 weeks. Pixel 6, I'm guessing, going to get some sort of announcement or event, sometime in the next month. And this is all guessing, of course, but it's all to say that we're within the prime territory where these leaks start coming a lot more rapidly, and we start to learn, a lot more official information from Google as we head towards Pixel season. So I know I'm excited. I imagine you're probably, at least intrigued to see where this is heading and everything.